Hello everyone. Today we are going to look at a simple tool which uses LLM to generate a simple design and test bench, and we simulate it using Verilog, and we will use the same LLM to summarize what it observed from compilation and simulation. So this is a overall view. So what it does is like so in this tool we have just hard-coded the prompt to generate the DUT into test bench, and we save the generated Verilog file, and we invoke the Verilog simulator to compile and do the simulation. So and based on the compile and simulation, we are using LLM tool to summarize compile and simulation results. So let's go. Okay. So this is a file. Okay. So the script starts from here. So prompt. So here I have hard coded the prompt. Maybe you can give it as a input to the Python file. You can do either way. So the prompt is like create a simple D flip-flop design in a Verilog without explanation, so that we can get a simple code without any explanation, and I am asked to include a dollar finish in the test bench. So we are just passing this prompt to generate and run. Okay. So in generate and run, we are creating a file called dflipflop.v, so which will save the design and test bench. Okay. So here we are calling Google. We are using Google Gemini 2.0 Flash model. You can use any other model you want, and here you need to use your key API key generated from Google AI Studio. You can just go to Google AI.studio, and you can select this Get API Key tab, and you can click Create API Key. You will get an API key. You can just copy paste in your project. Okay. So first thing is like we need to generate a Verilog file and test bench. So based on the prompt, we will get a response, which is a Verilog design test bench. So we will store it in Verilog code variable. So it will has the Verilog code. So if you want, you can print it in terminal. So I will just commented it. Okay. So next will be we are just saving the Verilog file, Verilog code in a file, and next will be Verilog part. So here we are invoking Verilog to run the compile and the simulation. Okay. So this is Verilog command, Verilog -o. I'm just directing it to store the output in dflipflop.output format, and I'm passing the generated design and test bench file. Okay, and I'm saving the compilation results in compile underscore results variable. Similarly, once compilation is done, we will invoke simulation command vvp.output file. Okay, so we're saving it in a simulation simulate underscore results. Once this is done, we are just collecting all information what we have done so far, so that our LLM can summarize what it understands. Okay. So here I'm creating a file called simulation underscore results.txt. So this text file has Verilog code which LLM generated, and compilation results. If it is passed, it will save here. If we get compilation error, it will write it in this file, and it will append the simulation results also. So everything will be in simulation underscore results.txt file. Okay. Once the compile and simulation is done, we have moved to the final part where we use GenAI to summarize what happened so far. Like what we are just going to ask what it understands from the design and test bench file. Okay. So this is a prompt we are passing to the Google Gemini. Okay. So summarize the following. So we are passing compilation output, simulation output, so that it can summarize what is happening. So this summary variable will host the summary output from the LLM, and we are just appending to log file, so which is nothing but a simulation underscore results.txt file. So now this pretty much this simulation underscore results has pretty much everything. Okay. This. Yeah. So now let's see it in action. So I have two files. So this is with API key and without API key. So what I have shown is without API key. You just need to use your API key to run the simulation. So I'm just calling it Python 3. Okay, so it has generated a Verilog code. Okay. Okay, fine. So the test got completed, and this is a summary which GenAI has given. So we'll see what are the files it generated. Okay. So it generated output file. This is from iVerilog compilation. This is D flip-flop, which is nothing but generated by LLM. You can just see what it has. Okay. So it generated D flip-flop, simple D flip-flop design, and it generated a simple Verilog test bench. Okay, and it's printing the. We are using it. It has used $monitor to print the results. Okay. So it's generated by LLM. So most of the time, the LLM will generate with language tag. So we need to clear or replace the tag. So here I have in the script I have used dot replace to replace this Verilog tag. Okay, so otherwise it will give a compilation error. So I have removed it beforehand. Once a response was generated, I'm just replacing this tag with nothing, null. Okay. Okay, so this is a file generated, and we can see the simulation underscore results, which has everything. Okay, so this is a generated Verilog code. Fine. Compilation output, so we don't see any errors in compilation. So this is a simulation output. So this is from a testbench file. So we can see it's generated clock design resets Q and Q bar. So pretty much, so we don't get any simulation error. So simulation got completed successfully, and we can see the results. Okay, fine. So now this is by LLM. So this is a simulation summary by LLM. So our LLM tells that the simulation got completed without any errors, and it tells that it's a D flip-flop design, and it just explains what it's happening. The simulation compilation simulation ran without error. So this is a summarization by LLM. Okay. So yeah, this is pretty much what this script does. From here, how we can improve. So, so initially we saw only this part: prompt, save file, iVerilog, and the prompt to summarize. So it ends there. So how you can further improvise is like you can prompt to summarize the compilation simulation output. Suppose you can, if there is a pass, we can leave it there. Suppose if there is a failure, you can generate or create a new prompt to rewrite the design based on the errors it observed. And you can again invoke the iVerilog simulation, and you can pass the results to LLM for summarization. And if it pass, it will end the script. Otherwise, you can ask the design to rewrite the failing part. So like this, you can just improvise the script which I have provided. So I think this is pretty much for now. See you on next video.